Hello, welcome to Now You Got It. In this video, you will learn about stacks and queues. So ready your eyes and ears, let's start. First is stacks. The elements of this data structure may be accessed from the item that was recently inserted. In real life, we have examples such as stack of chairs, stack of stones, and stack of cups. In data structures, a stack is used to store data such that the last item inserted is the first item removed. It is used to implement a last in, first out, or LIFO type protocol. An empty stack is one containing no items. Stack is a linear data structure where new items are added and existing items can be removed from the same end, which we call top of stack. The opposite end is known as the base. The figure in the screen shows the abstract view of a stack. Here are some methods we can use in stack data structure. First, stack method, which creates a new empty stack. IsEmpty method. It returns a Boolean value indicating if the stack is empty. Length method returns the number of items in the stack. Pop method. It removes and returns the top item of the stack if the stack is not empty. Items cannot be popped from an empty stack. The next item on the stack becomes the new top item. Next, peek method. It returns a reference to the item on the top of a non-empty stack without removing it. Peeking, which cannot be done on an empty stack, does not modify the stock contents. Push method. It adds the given item to the top of the stack. The stack data structure can be implemented in several ways. The most common approaches in Python includes the use of an array and a linked list. In the array, we add elements from left to right and use an variable to keep track of the index of the top element. First, let's consider how we implement a simple array-based stack. We look one index variable top, which points to the index of the most recently inserted element in the stack. To insert or push an element, we increment top index and then place the new element to that index. Similarly, to delete or pop an element, we take the element at the top index and then decrement the top index. In linked list, push operation is implemented by inserting element at the beginning of the list, while pop operation is implemented by deleting the node from the beginning. Now here is the comparison between array implementation and the linked list implementation. Let me show you an example problem in Python using the stack data structure. You can pause the video to analyze it carefully. Now let's go to queue's data structure. Queue is a list of data items, commands, etc. stored as to be retrievable in a definite order, usually the order of insertion. In real life, we have examples such as queue in a bookstore and queue in a bus stop. In data structures, a queue is a specialized list with a limited number of operations in which items can only be added to one end and removed from the other. A queue is also known as a first in, first out or FIFO type of data structure. Items are inserted into a queue at the back while existing items are removed from the front. Even though the illustration shows the individual items, they cannot be accessed directly. The items are maintained in the order in which they are added to the structure. Here are some methods we can use under the queue data structure. First is the queue method. It creates a new empty queue, which is a queue containing no items. IsEmpty method. It returns a Boolean value indicating whether the queue is empty. Length method. It returns the number of items currently in the queue. In queue that takes one item method adds the given item to the back of the queue. Dequeue method, it removes and returns the front item from the queue. An item cannot be dequeued from an empty queue. Two of the approaches to implementing a queue is using an array or a linked list. The simplest way to implement a queue data structure is to use arrays. It provides the necessary operations for adding and removing items at the respective ends. By applying these operations, we can remove items from the front of the list and append new items to the end. In the array, we add elements and use two variables to keep track of the start element and end element. Generally, front is used to indicate the start element and rear is used to indicate the end element in the queue. Under arrays are the circular arrays. A circular array is simply an array viewed as a circle instead of a line. A circular array also allows us to add new items to a queue and remove existing ones without having to shift items in the process. We assume the arrays as circular arrays. That means the last elements and the first array elements are contiguous or are attached to each other. To implement a queue as a circular array, we must maintain a count field and two markers. The count field is necessary to keep track of how many times are currently in the queue, since only a portion of the array may actually contain queue items. The markers indicate the array elements containing the first and last items in the queue. New items are added to the queue by inserting them in the position immediately following the back marker. For example, suppose we queue value 32 into the sample queue. To dequeue an item, the value in the element marked by front will be returned and the marker is advanced one position. Another way of implementing queues is by using linked lists. A major disadvantage in using a Python list to implement the queue data structure is the expense of the enqueue and dequeue operations. The circular array implementation improved on these operations, but at the cost of limiting the size of the queue. A better solution is to use a linked list consisting of both head and tail references. Enqueue operation is implemented by inserting an element at the end of the list. Dequeue operation is implemented by deleting an element from the beginning of the list. When dequeuing an item, we must unlink the node from the list, but return the item stored in that node, and not the node itself. Here is a sample problem in Python that uses the queue data structure. You can pause the video for analyzing it. Additional knowledge and summarization of the discussion. What are the differences in the array and linked list implementations of stacks? Explain the push and pop operations implemented using arrays and linked lists. What are the differences in the array and linked list implementations of queues? Explain the enqueue and dequeue operations implemented using arrays and linked lists. Now here's a question for you. What new knowledge about stacks and queues is the most interesting for you? Please comment your answer down below. And that's the end of the discussion, and I hope that now you got it. Feel free to comment down below your insights about stacks and queues to help your fellow learners. And don't forget to like and subscribe. Thanks for watching.